Problem 3. A 20-foot extension ladder propped up against the side of a house is not properly secured, causing the bottom of the ladder to slide away from the house at a constant rate of 2 feet per second. How quickly is the top of the ladder falling at the exact moment the base of the ladder is 12 feet from the house? So again, I'm going to start by writing down information that I know. I know the 20-foot ladder will never not be 20 feet, so I don't need to write any information down about that. It does say the bottom of the ladder is sliding away from the house at a rate of 2 feet per second. So I'm going to label this value down here x, and it's telling me how fast x is moving away. So they're telling me dx dt, and they told me that it is 2, and it is a positive because that x value is getting bigger. Okay, how quickly is the ladder falling? So if I'm looking for, it's actually asking me for how fast is this y value changing. So the problem is asking me for dy dt, and it asked me to find that when the base of the ladder is 12 feet from the house. So it's asking me for when x equals 12. Okay, so I have all my information. The next thing that I need is a formula. I do know that I have a right triangle and information about all three sides. So I am going to use the Pythagorean theorem, which would be x squared plus y squared equals 20 squared. Simplifying that a little bit, I'll have x squared plus y squared equals 400. And then from here, once I have my formula, I'm ready to take the derivative. The derivative of x squared would be 2x, but then I do have to include dx dt because I'm changing with respect to time this time. Plus, the derivative of y squared would be 2y dy dt, and then equals the derivative of 400, since it's a constant, is 0. Now I can just start plugging in what I know. I do know that x is equal to 12. I know that dx dt is equal to 2, and then plus 2. I do not know what y is, so it is definitely time for a side trip. We'll start with the formula. We do know that x squared plus y squared is equal to 400, and they did tell me that x was 12, so 12 squared plus y squared equals 400. 12 squared is 144, plus y squared equals 400. If I subtract 144 from both sides, I'll get y squared is equal to 256. And to get y, I'd square root. The square root of 256 is 16. So now I can put 16 in for my y, and then I will be looking for dy dt. And I do know that that equals 0. So working things out, 2 times 12 times 2 would be 48, plus 2 times 16 is 32. dy dt equals 0. I'll subtract 48 from both sides, so get 32. dy dt is equal to negative 48. And then I will finish my problem by dividing both sides by 32. And when I do that, I'll end up getting dy dt equals negative. And then if I divide 48 divided by 32, I'll get negative 1.5. And if I'm looking at how fast y is changing, and y would be measured in feet, and how often is it changing? Every second. Okay, please notice in this problem I did get a negative answer. That totally makes sense because my y value is getting smaller.